Guys, my name is Ibrahim Irsyad and this is my friend
Bismantaka
and
Basri ananta.
we are from group 6 and we're gonna tell you or we're gonna teach you about parallel computing. But first, the learning is from Taka.
Computation, parallelism and computing. A parallel computer is a set of processors that are able to work cooperatively to solve a computational problem. This definition is broad enough to include parallel supercomputer that have hundreds or thousands of processors, network of workstation, multiple processor, workstation, and embedded system. Parallel has sometimes been viewed as a rare and exotic subarea of computing, interesting but of little relevance to the average programmer. A study of trends in application, computer architecture, and networking so that this view is no longer tenable. Parallelism is becoming and parallel programming is becoming central to the programming enterprise. Next, trends in application. As computers become ever faster, it can be tempting to suppose that they will eventually become fast enough and that appetite for increased computing power will be set. However, history suggests that as particular technology service non-application, new applications will arise that are enabled by that technology and that will demand the development of new technology. The author of the report did not consider other applications in science and engineering, let alone the commercial application that will soon come to dominate computing. Similarly, the initial prospectus for cry research predicting a market for dense supercomputers many hundred have since been sold. Traditionally, development at the high end of computing have been motivated by numerical simulation of complex systems such as weather, climate, mechanical devices, electronic circuits, manufacturing processor, and semi-physical reaction. However, the most significant force driving the development of faster computers today are emerging commercial. Computer-aided diagnosis in medicine, parallel database used for decision support, and advanced graphic and virtual reality. Although commercial application might defend the architecture of most future parallel computing, traditional significant application will remain important user of parallel computing technology. They are also often characterized by large memory and input output requirement of, for example, a 10-year simulation of the Earth climate using a state-of-the-art model might involve a floating point. Science can easily imagine refinements to test model that would increase test computational requirement 100 times. Next, trends in computer design. The performance of the fastest computer has grown exponentially from to the present, averaging a factor of 10 every 5 years. While the first computer perform a 5/10 of floating point operation per second, the parallel computer of the mid at 10 of billion of operation per second. Next. However, the computer architecture used to sustain this growth are changing readily process to parallel. The performance of a computer depends directly on the time required to perform a basic operation and the number of these basic operations that can be performed concurrently. The time to perform a basic operation is ultimately limited by the clock cycle of the processor. That is the time required to perform the most primitive operation. To circumvent there's limitation, the designer might attempt to utilize internal concurrency in a chip, for example by operating on all of two numbers that are to be multiplied. This result means that not only it is difficult to build individual components that operate faster, It might not even be distributed to the shoe. It might be captured to use more slower components. For example, if we have an area of silicon to use in computer, we can enter build components as of size and able to perform an operation in time, or with a single component able to perform the same operation in time. The multi-component system is potentially n times faster. Next trends is in networking. Another important trend gaining the face of computing is an enormous increase in the capabilities of the networks that connect computers. Not long ago, high-speed networks ran at bits per second. By the end of the bandwidth in excess 4 bits per second will be in place. We emphasize that computing and networked computers with problems such as reliability, security, and heterogeneity that are generated as tenure in parallel computing. Continue by Basri.
Distributed concept. Distributed computing is a field of computer science that study distributed system. A distributed system is a model in which components located on network computer communication and coordinate their action by passing message. The components interact with each other in order to achieve a common goal. Their significant character of distributed system are concurrency of components, lack of a global clock, and independent flare of component. Example of distributed system vary from SOA-based system to massively multiplayer online games peer-to-peer application. A computer program that runs in distributed computer is called a distributed program, and distributed programming is a process of writing such a program. There are many alternatives for the message passing mechanisms, included pure HTTP, RPC like connector, and message queue. A goal and challenge pursued by some computer scientists and practitioners in distributed system is located transparency. However, this goal has fallen out of favor in industry as distributed systems are different from conventional non-distributed system, and the different such a network partition and partial system flare and partition upgrade can simple by paper over by atom and add transparency. Distributed computing also refer to the use of distributed system to solve computational problem. In distributed computing, a problem is divided into many tasks, each which is solved by one or more computer with communication with each other by message passing. Distributed systems are group of network computers which have the same goal for their work. They term concurrent computing, parallel computing, and distribution computing have a lot of overlap and no clear distinction exists between them. The same system may build character both as parallel and distributed. The processor in a typical distributed system run concurrently in parallel. Parallel computing may be seen as particularly coupled form of distributed computing, and distributed computing may be seen as a loosely coupled from a parallel computing. Nevertheless, it's possible to roughly classify concurrent system as parallel or distributed using the following criteria. We continue with Ibrahim Irsyad.
Topic is about parallel computer architecture. Parallel processing has been developed as an effective technology in modern computers to meet the demand for higher performance, lower cost, and accurate result in real-life applications. Concurrent events are common in today's computer due to the practice of multi-programming, multi-processing, or multi-computing. Modern computers have powerful and extensive software package to analyze the development of the performance of computer. First, we have to understand the basic development of hardware and software. Computer development milestone There is two major stages of development of computer, mechanical or electromechanical parts. Modern computer evolved after the introduction of electronic components. High mobility electrons is electronic computer replace the operational parts in mechanical computer. For information transmission, electric signal which travel almost at the speed of a light replace mechanical gears or levers. Elements of modern computers. A modern computer system consists of computer hardware, instruction sets, application program, system software, and user interface. The computing problems are categorized as numerical computing, logical reasoning, and transaction processing. Some complex problems may need the combination of all the three processing modes. Evolution of computer architecture. In the last 4 decades, computer architecture has gone through revolutionary change. We start with von Neumann architecture, and now we have multi-computer and multiprocessor. Performance of a computer system. Performance of a computer system depends both on machine capability and program behavior. Machine capability can be improved with better hardware technology, advanced architectural features, and efficient resource management. Program behavior is unpredictable as it depends on application and runtime conditions. Multiprocessor and computers. In the section, we will discuss two types of parallel computers. First, multi-computers and multi-computers and memory multi-computers. The most common shared memory multiprocessor model are uniform memory access. In this model, all the processors share the physical memory uniformly. All the processors have equal access time to all the memory words. Each processor may have a private chat memory. Some rule is followed for peripheral device. When all the processors have equal access to all the peripheral device, the system is called a symmetric multiprocessor. When only one or a few processors can access the peripheral device, the system is called an asymmetric multiprocessor.
Assalamualaikum warahmatullahi wabarakatuh. My name is Gilang Apriyana. This time, I want to share 3D programming material. What is 3D programming? What the heck? 3D is the smallest unit in a process that can be scheduled by the operating system. Okay, 3D programming. In computer science, a thread of execution in the smallest sequence of programmed instructions that can be managed independently by a scheduler, which is typically a part of the operating system. The implementation of thread and process differs between operating system, but in most cases in the thread in the component of the process, multiple threads can be accessed within one process, executing concurrently and sharing results as such memory. Sorry, my bad English. While different processes do not share these results. In particular, a thread of a process share its executable code and the values of its variables at any given time. System with a single processor generally implement multithreading by time slicing. The central processing unit (CPU) switch between different software threads. The context switching generally happens very often and rapidly enough that user perceive the thread or tasks as running in parallel. On a multiprocessor or multi-core system, multiple threads can execute in parallel, with every processor or core executing a spark thread simultaneously. On a processor or core with hardware thread, separate thread. Sorry, my bad English. Repeat again. On a processor or core with hardware thread, separate software thread can also be executed concurrently by separate hardware thread. Threads differ from traditional multitasking operating system processor in that processors are typically independent, while threads exist as subset of a process. Processors carry considerably more state information than thread, whereas multiple threads within a processor share process state as well as memory and other resources. Processes have separate address space, whereas threads that share their address space. Process interact only through system provide inter-process communication mechanism. Context switching between threads in the same process is typically faster than context switching between process. Thank you. Maybe that's enough from me. Sorry for my bad English.
Hello guys, my name is Dale and I will present you something about my specific study. It's about message spacing. Okay, let's start. In the computer science, message spacing is a technique for involving behavior, that is, running a computer on a computer. The invoking program sends the message to process, which may be an actor or object, and relies on the processor and supporting infrastructure to select and invoke the actual code to run. Message spacing differs from conventional programming, where a process subroutine or function is directly invoked by name. Message spacing is a key to some models or concurrency and object-oriented programming. Message spacing is used ubiquitous ubiquitous in modern computer software. It is used as a way for the objects that make up a program to work with each other, and as a means for object and system running on different computers, for example the internet, to interact. Message spacing may be implemented by various mechanisms, include channel. Message spacing is a technique for involving behavior for that is, pardon, running a program on a computer. In contrast to traditional technique of calling a program by name, message spacing uses an object model to distinguish the general function from the specific implementation. The invoking program sends a message to relies on the object to select and execute appropriate code. The justification for using an intermediate layer essentially fall into two categories: encal- encapsulation and distribution. Encapsulation is a idea that a software object should be able to invoke service on the other object without knowing or caring about how those services are implemented. Encap- Encapsulation can reduce the amount of coding logic and make system more manageable. That is, for example, rather than having if-then statement that determine which subroutine or function to call, a developer can just send a message to the object and the object will select the appropriate code based on this type. One of the first examples of how this can be used was in the domain of computer graphics. There are sort of complications involved in manipulation graphic object. For example, using the right formula to compute the area of an enclosed shape will vary depending on if the shape is a triangle, rectangle, ellipse, or cycle. In traditional computer programming, it should would result and long if then statement testing what sort of object the shape was and calling the appropriate code. The object-oriented way to handle this is to find a class called shape with subclass such a rectangle all ellipse, which in turn have a subclass square and circle, and then to simply send a message to any shape asking it to computer its area, its shape, Object will then invoke the subclass method with formula for that kind object. Distributed message spacing provides developers with a layer of the architecture that provides common service to build system made up of subsystems that run on disparate computers in different locations and different time. When a distributed object is sending a message, the messaging layer can take care of issues such as finding the app using different operation systems and programming language at different locations from where the message oriented, saving the message on the queue if the appropriate object to handle the message is not currently running, and then invoke the message when the object is available, also storing the result if needed until the sending object is ready to receive it. Controlling various transaction requirements for distributed transaction. For example, ACID testing the data. One of the most important distinctions among message passing is whether they use synchronized or asynchronous message passing. Synchronous message passing occurs between objects that are running at the same time, which asynchronous message passing is possible for the receiving object to be busy or not running when the requesting object sends the message. Synchronous message passing is what typical object-oriented programming language such as Java and Smalltalk use. Asynchronous message passing requires additional capability for storing and retransmitting data for a system that may not run currently. The advantage to synchronous message passing is that it is conceptually less complex. Synchronous message passing is analog to function call in which the message sender is the function caller and message received is a called function. Function calling is easy and similar, just as the function caller stop until the call function complete. The sending process stop until the receiving process complete. This alone makes synchronous message unworkable for some applications. For example, if synchronous message passing will be used exclusively, large distributed system generally would not perform well enough to be usable. Such large distribution systems may need to continue to operate it while some of the subsystems are down. Subsystems may need to go offline for some kind of maintenance or have time when subsystems are not receiving input from the other system. My God, banyak. Image a busy business office having 100 top computer that sends email to each other using synchronous message passing exclusively because the office system does not use a synchronous message passing. One worker turning off their computer can cause the other 99 computer to freeze until the worker turn their computer back on the processor a single email. Asynchronous message passing is generally implemented so that all the complexity that naturally occur when trying to synchronize system and data are handled by a intermediary level of software. Commercial vendor who develop software product support this intermediate level usually call their software middleware. One of the most common type of middleware to support asynchronous message is calling message-oriented middleware or MOM. MOM. With a coarse message passing, the sending system does not wait for a response containing the function called analogy. Asynchronous message passing would be a function called the return immediately without waiting for the called function to execute. Such an synchronous function call would merely deliver the arguments, if any, to call function, excuse me, and tell the called function to execute and then return to continue its own execution. Asynchronous message passing simply send the message to the message bus store. The message will until the receiving process requests message sent to it. When the receiving process arrives and the result, it sends the result to the message bus, and the message bus holds the message until the original processor or some designated the next processor picks up its message from the message bus. Synchronous communication can build on the top of synchronous communication by using a synchronizer. For example, the synchronizer works by ensuring that sender always waits for acknowledgement message from the receiver. Sender only sends the next after the acknowledgement has been received. On the other hand, a synchronizer, a synchronous communication can also be built on the top of synchronous communication. For example, modern microkernel generally only provide a synchronous messaging primitive, citation needed, and asynchronous messaging can be implemented on top by using helper thread. The buffer required asynchronous communication can cause problem when it is full. A, a decision has to be made whether to block and the sender of the whether to depart future message. If the sender is blocked, it may lead to be unexpected deadlock. If messages are dropped, then communication is no longer reliable. The- These are these are all examples of the kind of problem that middleware vendors try to address. Okay, the next one is CUDA. CUDA is a parallel computing platform and application programming interface AI model created by NVIDIA allows software developers, software engineers to use CUDA enable graphic processing unit for general purpose processing and approach termed general purpose graphic processing unit. The CUDA platform is a software layer that gives direct access to virtual instruction set and parallel computation element for the execution of computer kernel. The CUDA platform is designed to work with programming languages such as and Fortran. This access makes it easier for specialists in parallel programming to use to research. In contrast, your API likes Direct 3D and OpenGL, which support advanced skill in graphic programming. Also, CUDA support programming frameworks such as OpenAC and OpenCL. When it first introduced by NVIDIA, the name CUDA was acronym for Compute Unified Fast Architecture, but NVIDIA subsequently dropped the use of the acronym. This graphic processing has special computer processors address the demands of real-time high-resolution 3D graphic compute intensive text. By 2012, has involved highly parallel multi-core system allowing very efficient manipulating of large blocks of data. Design is more effective than general purpose central processing units (CPUs) for algorithms in situations where processing large blocks of data is done in parallel, such as bus reliable maximum flow algorithm, fast sort algorithms of largely two-dimensional fast wavelet transform, molecular dynamics simulation, programming abilities. Example of CUDA processing flow: copy data from main memory to memory. CPU initiates the GPU compute kernel. GPU CUDA core execute kernel in parallel. Copy the result data from GPU main memory. The platform is accessible software developers through CUDA accelerated accelerated libraries, compiler directives such as OpenACC, and extension standard programming language include and Fortran. C or C++ programmer use the C or C++. Compile with NVIDIA LLVM-based C or C++ compiler. Fortran programs can use the Fortran compile with GIQ the Fortran compiler from the Portland group. In addition to library compiler directive CUDA C or C++, the Fortran the CUDA platform support other computational interfaces, the Kronos OpenGL, the OpenGL Compute Shader, MP. Third-party wrappers are also available for Python, for Fortran, Java, Lua, Common Lisp, Haskell, R, MATLAB, IDL, and native support in Mathematica. In the computer game industry, are used for graphic rendering and for game physics calculation. Physical effects such as debris, smokes, fire, fluids. Example include physics, X, and bullet. CUDA has also been the red non-graphical application in computational biography and other fields by an order magnitude or more. CUDA provides both a low-level API and higher-level API. The initial CUDA SDK was made public on 15 February 27 for Microsoft Windows and Linux. Mac OS X support was later added in version 2.0. It suppressed the beta release February 14, 28. The works with all NVIDIA GPUs from the 9X series ports, including GeForce Quadro and Tesla line. CUDA is compatible with most standard versions. NVIDIA stated that program developed for the 8 series could also work without modification on all future NVIDIA video cards due to binary compatibility. CUDA 8.0 comes with following library for compilation and runtime in alphabetical order: plus CUDA basic linear algebra, Cronus library, cpan and doc, dart, dart running time library, docs, CUDA fast Fourier transform libraries, cpan and run CUDA random number generation library, cpan and doc. To solve first, CUDA based collection of Booleans and spread direct solver, cman and docs. To sparse CUDA, sparse matrix libraries, and docs. NPP NVIDIA performance primitive library docs. NVGraph NVIDIA Graph Analytic Library, NVML, NVIDIA Managed Library, NVRTC, NVIDIA Runtime Compilation Library from CUDA C++. CUDA 8.0 comes with this other software component. View, NVIDIA Export Management Software, NVWMI, NVIDIA Enterprise Management. PsyX, GameWorks PsyX is platform game Psy engine.
Okay guys, that's all. Udah tadi belum pas tiganya? Okay guys, that's all from my group, our group. So that's about parallel computer. And thanks for watching this video and see you next time in other video. Please subscribe. Bye bye.